Here we have a particle with a 10 millicoulomb charge is placed at the origin, and another particle with a 5 millicoulomb charge is placed at 1 meter. We want to know where the field due to these charges is 0. So let's start by drawing a picture. Here is our 10 millicoulomb charge. Here is our 5 millicoulomb charge. Now we have three choices for where our answer could be. It could be to the left of our charges, it could be in between our charges, and or it could be to the right. So let's do a simple exercise and just see what the direction of the fields are in each of those three positions, to see if they could actually cancel each other out to be 0, which is what we're looking for. So we start with the left. So at some point over here, we're going to get a field due to the 10 millicoulomb charge going to the left. 1 due to the 5 is also going to be going to the left. So these can never cancel out to be 0. They're both going in the same direction, so we know anything to the left of our answer is no good. We're not going to find a solution there. If we look at the right of our charges, over here somewhere, we're going to get a field to the right due to the 10, a field to the right also due to the 5. Again, because both fields are in the same direction, they cannot cancel each other out, so this is no good either. So that means our answer must lie in the middle somewhere. So I'm just going to pick a position. Let's just say here's where our guess is. Now the field at this spot we want, we could have a field due to the 10 is going to go to the right. The field due to the 5 is going to go to the left. So there is a position in this area in between the two charges somewhere where these fields will be exactly the same size but opposite directions, and they could cancel each other out, and you would have a 0 net field there. So now that we figured out where our answer is going to be, let's define it in some way. So we know when we're finding fields due to point charges, we need the charge, which we have. We also need the distance from the charge to the point in space we're talking about. So let's call this distance d10. So it's the distance from the 10 millicoulomb charge, and call this guy over here d5. Now we can set up a sum of the fields equation. Sum of the fields here is going to be, in this case, E10 minus E5. We want them to be equal to 0. Putting our definition, these are point charges, so we can use Coulomb's law for our fields. So this is going to be K Q10 over D10 squared minus K Q5 over D5 squared. And we can do a little bit of canceling out. We can drop out the K's and then bring this to the other side. So I'm just going to set them equal to each other. And it looks like we have a fairly simple equation, but if you notice, there's a problem. We have two variables and only one equation, which means we can't solve this yet. So we have to be a little bit sneaky. If we go back to our picture, we were told that these charges are 1 meter apart. So let's write one of our distances in terms of the other distance in this 1 meter. If they're 1 meter apart, and let's say we call that D10, D3 then is actually equal to 1 meter minus D10. So we can substitute this in to our equation over here. It'll get rid of a variable, and then we can solve this. So this turns into Q10 over D10 squared equals Q5 over, now this is 1 minus D10 squared. Okay, and again, alright, this might look a little bit ugly. Let's put some numbers in and see what happens. Let's see, this turns into 10 millicoulombs. Actually, we don't need the millicoulombs because they're on both sides. So the units are going to drop out also here. So we have 10 over D10 squared equals 5 over 1 minus D10 squared. We can do a little canceling. And now the easiest way to solve this problem is to square root the entire equation. So if I square root the entire thing, this becomes, let's see, the top is square root of 2. D10 squared, the square root of that is just D10, equals the square root of 1 is still just 1, and the square root of 1 minus D10 squared is just 1 minus D10. That's a lot simpler looking. We can cross multiply. So this becomes radical 2 minus radical 2 d10 equals d10. Do a little bit of algebra. We get that d10 equals radical 2 over 1 plus radical 2, and do a little typing on your calculator, and we get that d10 is actually equal to about 0.0 or 0.586 meters, which means that the position on this diagram where the field is 0 is 0.586 meters to the right, because that's what we call d10 of our charge, of our 10 millicoulomb charge.